So next would be our water treatment. So what is water treatment? Treatment can be classified as mechanical, thermal, and chemical. Mechanical treatment are treatment are the following, which is desedimentation, filtration, and interior painting. So distillation and derivative heating are thermal processes. So chemical treatment may consist of chemical reactions with prepared reagents to cause precipitation or maybe exposure to cellulite in order to obtain an ion exchange. So what is ion exchange? It's always carried out on makeup or fed water. So that is ion exchange. Next would be internal treatment is widely employed by operators of small boilers and by others whose fed water problem is not intensified with the presence of large ppm of dissolved salts in the water. So some of the chemicals employed internally are sodium hydroxide, which duty is to establish alkaline pH and precipitate magnesium. Next is sodium carbonate to precipitate calcium, sodium aluminate to coagulate finely divided precipitates into a flux, also to precipitate calcium and magnesium. So sodium phosphate to precipitate calcium in the form of favorable to reduce through blowdown. The trisodium phosphate reaction is this. So sodium sulfate to complete the oxidation. Colloids protect colloids such as tannin and reactive organics forms to make a fluid sludge of suspended particles. So acid is to control alkalinity. A typical reaction is the following. So next is the table 13-5, which is the summary of water treatment. So we have here our impurity, oxygen, carbon dioxide, calcium, magnesium, salt, and etc. So we have trouble. So for oxygen, we have corrosion. So for the limit of tolerance in fed water, so we have 0.03 CE per liter. And kind of treatment is the chemical deoxidation, thermal, duration, and etc. Next would be the external water softeners are divided into precipitation and ion exchange types. So the figure shows the hot process lime soda or softener with derator section. So this is how it looks like. In the lime soda treatment reaction are presumed to be the following. So our next slide would be the fed water heating. So what is it? So it is refer only to equipment obtaining heat from the steam. So it only obtains heat from the steam. Fed water heater is divided into two classes, which is the contact and the surface. So next would be our contact heaters, which is open and jet heaters constitute this class. The open heater is ordinarily built up in a rectangular form, but heaters for the other near atmospheric pressure are constructed in cylindrical form of steel plate. So this one is a rectangular, is built in rectangular form. And next would be the rating heaters, which is the role of oxygen as a corrosive agent, has already been explained. It is desirable to reduce the oxygen content of fed water to zero or practically so. So heating of water to 104 to 110 degrees Celsius with subsequent agitation is capable of freeing the water from this gas. So while the activation had been accomplished by chemical reaction and by water flushing, the trend is toward tray-type contact heating using steam at. So we have a 0.35 to 0.7 kilogram per cubic centimeters GA in contact mixing. So by operating or gallons in contact mixing by operating at a plenum, the liberated gas can simply be released to the atmosphere on all On all but small size units, the released air vapor mixture first passes through a vent condenser so that finally only the gas is discharged. Next would be the surface heaters, or the surface heaters are divided into steam tube and water tube type. So it has two ano two classification. Steam tubes are ordinarily used in evaporators, but most extraction heaters of the water tube type. These heaters can also be divided into straight tube and bent tube, U tubes, and steam coils in into a single or multi-pass. So next would be our evaporator. So the function of evaporator is to produce from raw water vapor that can be condensed to distilled water for boiler-fed makeup. Evaporator were first used in marine practice as a matter of necessity, but their use has extended to land practice, especially the central station. So it is primarily in the marine field. The So an evaporator system may be single effect in which the steam is produced from one evaporator, or multiple effect in which the steam is produced from several evaporators in series. So the figure shows the connection of extraction heater to turbine nozzle, and next would be the evaporator paralleled with reducing valve for supply of industrial steam. So next figure would be the two effect parallel fed Hatex level evaporator plant showing interconnecting piping by and automatic devices for maintaining constant water levels in evaporators. So next would be our water pumps. So the water loop is activated by pumps. So the regenerative cycle with its extraction heaters, aerator, and other auxiliaries presents numerous requirements for moving water from one place to another, as well as of increasing its pressure. The function of a pump is to add the pressure existing on a liquid and increment sufficient to the required service. So the principal types in power plant service are reciprocating, rotary, and centrifugal pumps. So these are the three. So jet pumps are represented by the boiler injector are comparatively unimportant in this field, though sometimes used as emergency fed for small boilers. So rotary pumps are all types of operating on pure rotation, excluding centrifugal force as partial building action. The principal example is a turbine type pump. So the purpose of a pump is to move a quantity of water against a pressure, so that's its main purpose. So essential to any quantitative discussion of performance, capacity, and etc. the following terms and definition. So uppercase Q is the pump discharge liter per minute. So 1,000 liters, or the cube is equal to 1 cubic meter. So uppercase H is head meters of water of specified density at ordinary temperatures. 1 kilogram is equals to 1 liter, and 1,000 kilogram is 1 cubic meter, and 1 kilogram per cubic meter to 10 meters. However, this constant should not be used in hot water calculations unless the density error can be counterbalanced. So lowercase d is the water density kilogram per cubic meter, reciprocal of V from the steam tables. Static head is the height, usually in meter, of surface of water above the gauge point. Next is pressure head is the static head plus gauge pressure on the water surface plus friction head. So velocity head is the head required to produce a flow of water. Dynamic head is the pressure head plus the velocity head except for water velocities considerably above average or for large volumes handled at low heads and the velocity head can be neglected. Next would be the pump operating head, which is the algebraic difference of discharge and suction heads. This can also be called total dynamic head and abbreviated by the TDH. Net positive suction head is abbreviated NPHS, is defined as the dynamic pressure of the liquid at pump suction, kilogram per cubic centimeters, less the saturation pressure corresponding to the temperature at same point converted to meters head of the liquid. Next would be the specific speed of a centrifugal pump impeller is the rotative speed at which a geometrically similar impeller would run if it were of such size to raise 75 kilograms of water per second against 1 meter head.